It begins with silence. Not the kind you hear, but the kind you feel. A place so cold that motion itself almost stops. Because temperature is not just about heat, it's about movement. The faster particles move, the hotter something is. The slower they move, the colder it becomes. So what happens when motion nearly disappears? You reach a limit, a temperature that cannot be crossed. Absolute zero, minus 273.15 degrees Celsius. At this point, atoms barely move. Energy is almost gone. This is the coldest temperature physically possible, and yet the universe comes surprisingly close. Far beyond Earth, past the planets, past the stars, there are places colder than anything we can imagine. One of them is not where you might expect, not in deep space, but right here in our own galaxy. The Boomerang Nebula, a dying star, casting off its outer layers. But something unusual is happening. The gas is expanding, extremely fast. And as it expands, it cools, rapidly, so rapidly that it drops below the natural background temperature of space itself, reaching nearly 1 degree above absolute zero, colder than anything else ever found in nature. But to understand how cold that is, we need to zoom out, because space itself is not completely cold. Even in the darkest void, there is still a faint glow, a leftover signal from the birth of the universe. The cosmic microwave background, it fills all of space. A temperature of about 2.7 Kelvin, just above absolute zero. This is the baseline, the natural temperature of the universe. Everything eventually cools toward it. But the Boomerang Nebula goes even further. It creates its own pocket of deeper cold, a place where energy is drained faster than the universe can replace it. But here's something even stranger. The coldest place ever recorded is not in space at all. It's on Earth. Inside laboratories, scientists have pushed temperatures even lower. Using lasers and magnetic fields, they slow atoms down almost completely, reaching billionths of a degree above absolute zero, colder than any natural place in the universe. At these temperatures, matter behaves differently. Quantum effects take over. Atoms begin to act like waves. Separate particles merge into one. A new state of matter emerges. A Bose-Einstein condensate, a single quantum system acting as one. This is not just cold, it is a completely different reality. So, what is the coldest place in the universe? Naturally, it may be the Boomerang Nebula. But artificially, it exists here, on Earth, in controlled environments, where we push physics to its absolute limits. And yet, we can never reach absolute zero, because removing the last bit of energy is impossible. There is always some motion left, some uncertainty, some trace of energy. So the coldest place in the universe is not a single location. It is a limit, a boundary defined by the laws of physics themselves, a place we can approach but never reach. And in that silence, where motion nearly disappears, we begin to see the universe in its most fundamental form. Quiet, still, and almost frozen in time.